So 7.1 was talking about ratios and talking about proportions. Let's just quickly recap that. When we talked about a ratio, like 1 to 2 was a ratio, right? But then if we set it equal to what it's equal to, I mean, you can think of anything, maybe like 3 to 6. Would you agree that they're equal to each other? Yeah. So if you have a fraction set equal to another fraction or a ratio set equal to another ratio, then this whole thing is called a what? What's this whole thing called when a fraction set equal to another fraction? Anybody remember it all? No? Nobody was here? Was I the only one here the other day? Starts with a P. We've talked about this. This is nothing new. Proportion, right? It's called a proportion. Right? That's old stuff. That's not what we're doing brand new today. Right? So proportion. You need to know that. When a fraction is set equal to another fraction, we call that whole thing, this whole thing right here, we call that a proportion. Everybody got that? What's just one of these things? What is it when you can just compare one number to another number? What is that? It's a ratio. All right. So basically, a ratio, or I'm sorry, a proportion, it's two ratios set equal to each other, and they have to equal each other. Now, would that be a proportion? No. I mean, they are two fractions, and you got an equal sign in between them, but they're not equal, are they? How can you tell if they're equal or not? I mean, you could just reduce the fraction, but you could also do what? What did we talk about? Cross multiply, right? So we could cross multiply. If we cross multiply and they're equal, then the fractions are equal. Let's do this real quick. 1 times 6 is 6. 2 times 3 is 6. 6 equals 6. So yes, that is a proportion. What about this? Let's multiply that together. 1 times 7 is 7. 2 times 5 is 10. Put a question mark right here. Is 7 equal to 10? No, of course not. So is that a proportion? No, it's not a proportion. It's when the fractions are equal to each other. Two fractions are set equal, but they do have to equal each other. That's called a proportion. Everybody with me on that? All right, that's easy stuff. Let me just get rid of that. So what we're going to do today is we are going to talk about different shapes, obviously. That's what we've been doing all year long in geometry, isn't it? So we're going to talk about different shapes. And I'm going to grab a picture here. You mean use the same picture or a different picture I used in the other class? Different. Let's use this lovely picture right here. I took this in Gettysburg, Pennsylvania. Some girl from, she's from New York. She's a student of one of my friends who's a yearbook advisor and a teacher up in New York State. And she goes to his school. So anyway, just using this just for the sake of having a picture. Now watch what if I did this. What if I copied and pasted it? All right. Tell me something about these two pictures as far as geometry is concerned. They're congruent. Very good. Okay, they're both exactly the same, and they're congruent. Now, let's do this. I'll tell you what. What if I did this? Let's get rid of that. I'll bring it back in a second. What if I made? What if I just grabbed this end right here and did? I'll tell you what. Let's just make this bigger. Okay. What if I did this? What's it gonna do? I didn't let go yet. What's it gonna do? It's gonna shrink it. It's gonna compress it. It's gonna make it skinnier, isn't it? Okay. It's not just gonna shrink it, but it's gonna make it a little skinnier, and so it's gonna look weird. Okay. That looks different from what I had originally. Would you agree with that? In fact, kept on debating whether I was going to copy and paste this, and let's just go ahead and do that. All right, so, and let's compare it to the original. All right, so I'm going to take this one, I'm going to bring it in like this, and that's definitely doesn't look, now it includes everything in this picture, doesn't it? You see that? It includes everything, all the sky and the little trees over here and the rocks and all that kind of stuff and her silhouette. It includes everything, but it looks a lot different than this, doesn't it? It doesn't look right, does it? Okay, what do we say then? We say that the picture is not in what? Proportion. Very good. Okay, it's not in proportion. What if I did this? What if I took this end and whoops, I'll tell you what, let's scooch this over just a little bit. If I took this end right here and I did this to it. What do you think that's going to do to your picture? It's going to make everything wider. It's going to stretch it out, right? She added a couple pounds, didn't she? All right. So is that in proportion? No, it's not. Okay, it's not in proportion. Okay, it doesn't really look the same as this looks right here, does it? What else could you do to it? Watch this. What if I wanted to make this a little smaller, but I wanted to keep it in proportion? Okay, I didn't want it to be skinny. I didn't want it to be, right? I mean, I could have done this too to make it a little fatter, couldn't I? See how it kind of squished it up and down? You can do a lot of different things. You can even take the corner. Whoops. You can take the corner. Oh, come on, grab the corner. There it is, right? And you could do this. You can make it skinnier and smaller and everything else. I've seen people's projects um, where you try to, you have a certain space for your picture, and so here's your picture, and you need to fit it into a certain space, make it maybe like a square space, and what do people do? They'll go like this to get it to fit, but what happens to your picture? It becomes out of proportion, doesn't it? It's not in proportion. That's my pet peeve when it comes to that kind of stuff. And I do a lot of this kind of stuff because we work on yearbook, and and people could try to fit a picture into a spot by doing that. But I don't ever want a picture being, a different proportion than what it's supposed to be, than what it originally was. All right, so how do I do that? How do I make this picture smaller but keep it in the same proportion as what this original picture is? Does anybody know how to do that? Now, this really doesn't have much to do with geometry, but since I've got these pictures up here, I thought I'd teach a little bit of desktop publishing tricks. Okay, now I could just grab this, right, and just say, well, that pretty much looks like it's in proportion, right? Yeah. But do I know for a fact that it's in proportion? Nah, because that might have been up a little bit more than I wanted to, or maybe a little bit down than I wanted to. And that's just not really sure. So how do I do that? I grab a corner, but I hit something on the keyboard. Anybody ever do this before? See, this is good to show you this, because then when you do these projects, when you do, what do you guys like, in 10th grade mostly? So when you're in 11th grade and you do your History Day project again, remember those good old days from 8th grade? Okay, when you're in 11th grade, you're going to do a History Day project, and a lot of people take pictures, and I look on the History Day projects, and they look, some of them look bad because the pictures are all wacky looking. So what do? You hit the Shift key, watch, hit the Shift key, shh, hey, I'm up here. All right, concentrate on what I'm telling you. Just because I said History Day doesn't mean you have to have a big discussion about what's going on for History Day, all right? Just take it for what it's worth. So what I did is I hit the Shift key. Look what happens. Look at the sides. Now, the picture's getting smaller, but the sides are changing in proportion. Do you see that? Yeah. So the top isn't getting longer in the up and downs, let's call it the width and the height. So the width isn't getting longer and the height's getting shorter. I mean, as the height gets smaller, the width gets smaller, right? In the same exact proportion. That's when you hit the Shift key. So that's a good hint for you when you're doing projects like that, or you're doing something with pictures, okay? So hit the Shift key, hit the corner, and it's going to keep the thing in proportion. You follow me on that? Okay, let's do this. Let's just assign some numbers to this. Let's say this is 8 and this is 12. We'll call this 8 by 12. All right. If you get a picture, like you put it on the wall, I don't see any pictures around here about, yeah, maybe, do you see the pictures over there by my desk? Yeah. The kayaking pictures? It looks like they're probably about what size? Anybody know their picture sizes? 8 by what? Yeah, usually about 8 by 10 is what we get. But if you look at those pictures, see the very bottom picture of all the people? That was the first senior class that I taught here. So that bottom picture right there is actually an 8 by 10. An 8 by 10 actually cuts off a lot of the width of your actual picture that you're taking. So if I and you know that from black and white. When we took black and white class, we take the picture, and if you wanted to make this 8 by 10, you would have to actually cut off about right here to make this 8 by 10. An actual picture is more like an 8 by 12 format. Okay, pretty close to that. In fact, yeah, it's exactly that. Nah, it's close to that. Not exactly, but it's close to 8 by 12. So what if this right here, what if this was 3? It's a weird looking 3. There we go. What if this was 3? What do you think this is going to be right here? Because if this goes 12, 8, what's this going to go? Right, because we took 12 and we did what to get 4? Divided it by 4, didn't we? So we take this and we divide it by 4 to keep it in the same proportion. What do we get? We get a 2. So 12 by 8, excuse me, is the same proportion as 3 by 2. Does that make any sense? All right. So we would say that they are in proportion. How can you check to see if it really is in proportion? Well, you take 8 by 12, right? 8 to 12. What would you set that equal to? If I went 8 to 12, what would I do over here? 2 to 3. That's right. And then you would see if they're equal to each other. What's 8 times 3? It's 24. What's 12 times 2? It's 24. They are equal to each other, so they are in proportion. You with me on that? So this is a very important thing, okay, when you're talking about photography and things like that, is to make sure your picture is in proportion. But what kind of a figure is this? This is a four-sided figure, and more specifically, what do you think? Looks like a what? Yeah, looks like a right angle, right? Pictures normally, okay, are right angles right here. So what kind of a shape do we have here? It's a rectangle, okay? So we have a rectangle right here. Now, when we talk about these things, when they have the same proportion, both of these, the ratio between this and this are exactly the same. They are in proportion, aren't they? So when you have, and all the angles are equal, right? We got right angles here, right angles all around, and the sides are in proportion. When those two things are true, we have two things that are called similar polygons. Write that down. Similar polygons. Anything I write down, you should be writing down. Okay, I shouldn't even have to tell you. You should be writing it down anyway. So in order to be similar polygons, they're not congruent. Would you agree that these two pictures are not congruent to each other? Yeah, because in order to be congruent, they would have to be exactly the same. Same angles, right? All the angles must be equal, and all the sides must be equal. But they're not congruent to each other. They are what? Similar. They're similar. And two things must be true to be similar. All the corresponding angles have to be equal to each other. Write that down. The corresponding angles have to be equal to each other, or you could say congruent, whatever you want. And look, if I took this picture right here, picked it up, and put it up here, all those angles match up, don't they? They're all right angles. Everybody see that? All right, so that must be true. But just because all the angles are equal to each other, does that mean it's congruent? No. Or does it even mean it's similar? No. What has to be true about the sides? What did we just say about the sides? The sides are in what? What did I show right here? Or in proportion, okay? And that's what I'm going to write right here. Actually, I should say the corresponding sides. I'll just shorten corresponding. Is that right? The corresponding sides are in proportion. They don't have to equal each other, but they do have to be in proportion. And again, what does that mean? If I compare one side to another side, it's going to equal the same corresponding side to the other corresponding side. I could compare it a couple ways. I could go 8 to 12, and we just saw that that's equal to 2 to 3, isn't it? What's another way do you think I can compare it? I could compare 8 to what? What side over here is corresponding to this 8? To 2, right. So I could compare 8 to 2. Let's try that. If I could compare 8 to 2, that should equal what? 12 to 3. Let's see if that equals. Does that equal? Sure. 8 over 2 is 4. 12 over 3 is 4, isn't it? Or if you wanted, you could do this. And you still get the same exact numbers, don't you? See that? So the sides have got to be in proportion in order to be a similar polygon. So that's very, very important right here. Very important. All right? Put a box around it. It's that important. All right? To put a box around it. So that's similar polygons. The corresponding angles have to be exactly the same, but the corresponding sides are in proportion. Let's do this with something that's not a picture and not a rectangle. Let's do this with, let's come up here and find just a regular old triangle. And let's scooch down a little bit. And we'll put that right here. And we have a symbol for the word similar. Actually, let me put that about right there. And let's just make that a little bit smaller. And let's label these before we do anything else. Let's label it ABC. And we'll call this DEF. Alright? Now, I'm going to tell you this. I'm going to tell you that triangle ABC is similar. Now, here's the symbol for similar. Okay, it's kind of like congruent. That's the congruent symbol, but it's congruent without the equal sign. It's only the squiggle. All right, so it's only just one squiggle, not two, just one squiggle. You guys writing that down? So triangle ABC is similar to triangle, we'll call this DEF. Now, what if I told you that? Okay, I told you that that's true. What must be true about these two triangles? Well, the corresponding angles have got to be what? Equal to each other. So look up here. I drew this, or I wrote this little, not congruency statement, but similarity statement, so that the A and the D match up. So what do you think might be true about the angle A and angle D? They're equal to each other. Exactly right. And what about B and what else? What do you think angle B equals over here? Angle E. So we'll mark that. And of course C equals F. Okay? Now, we'll put this back in a second, but watch. If you don't believe me, I'll take this triangle and put it right on top of there. Look at angle A and look at angle D. They match up perfectly, don't they? Follow me on that? Okay, let's go down to angle B and angle E. Look at that. They match up perfectly, don't they? See that? And then come over here, and both of those angles are equal. Now, does that mean that the triangles are congruent? No. It means that they're similar to each other. I didn't put two arcs here, did I? Okay. All right, that's pretty important right there. So the A and the D match up, the B and the E, and the C and the F. Now, here's the part that's a little bit tricky. I'll tell you what, let's just write that down. So, first of all, angle A equals angle D. And I'm just going to just write along here. Then angle B must equal angle E. Now, we've talked about this already. I just want to write it down. Then angle C equals angle F. So those are my corresponding angles, and they have to equal each other. What about the sides, though? Which ones are the corresponding sides? Look at AB, and you can even come over here and look. Look at AB. What does AB correspond to over here? DE. Do you see that? You don't even have to look at the picture, do you? You can just look at this little similarity statement and say, oh, AB and DE go together. Does that mean they're equal to each other, though? Now, look at AB and look at DE. This is way bigger, isn't it, than DE? So they're not equal to each other, but they are in proportion. And what does that mean? Well, it means that we can set up some ratios. Watch this. So let's compare AB to its corresponding side. What corresponds to side AB over here? DE. So I'm going to put that underneath. Remember, we're making proportions, aren't we? And proportions are ratios set equal to each other. So look, I compared AB to DE. What other side could I compare? Let's go AC. What does AC correspond to over here? DF. Now, they're not equal to each other, so we don't set them equal, but I can say that AC over DF is equal to AB over DE. Everybody see that? And then what's the third one? BC. And what am I going to compare that to? EF. All right? And if you notice, come up here again and look at it. This thing is really important. Don't just think they just throw that thing out there just because they think it looks nice. Okay, it really, really is helpful. So AB goes to DE. Look at AC. AC is the first and the third one, right? AC goes with what? DF, or corresponds with it. And what else? BC, which is the last two, equals, or not equals, but corresponds to EF. So there's two things. The angles are equal to each other, and the sides are in proportion. And that's how we're going to write the sides in proportion. The angles equal to each other, we got that stuff down. We've been doing that kind of stuff almost all year. This is a little bit different, okay? The sides are in proportion. That's really, really important for us to see. Make sense? Yeah. All right. Now what I'm going to do is do another figure. Hopefully you got all that written down. Let's do this. Let me draw the triangles so it kind of looks like the one in the book. Looks kind of like that. Looks kind of like that. Alright, so draw that triangle. I'm going to group it, and I'm going to copy, and I'm going to paste it. And I'm going to make it a little bit smaller. So I grab it, hit the shift key. Hitting the shift key keeps it in proportion. Remember that, right? So I make it a little bit smaller. Now what's true about these two triangles right here? They are in what? I'm sorry, I shouldn't say that. The sides are in proportion, but the two triangles are what? Similar to each other. Good. Watch what I'm going to do, though. Does this change the fact that it's similar? Watch what I'm going to do. I'm going to take this triangle, and I'm going to twist it. About like that. Now, I didn't change the sides, did I? I didn't change the angles. And then I'm also going to do this. I'm going to, well, I just rotated it. I'm going to actually reflect it. There we go. Do you see how it, see that's the way it did look right there? And then that's what I did to it. Everybody see that? Did I change the angles at all? Did I change the lengths of the sides at all? Nope. Just flipped it, twisted it around. That's all I did. Okay? Everybody with me on that? Let's call this ABC. And let's call this XYZ. And here's what they tell you again. They tell you that they are similar. So it says triangle ABC is similar to triangle XYZ. So that's given, okay? They tell us that thing right there. We didn't assume it. They told us that that was true. They said, we drew it, so that's true. All right? And they're going to put some numbers in here. They said AB is 6 and XY is 3. What we're going to show you right here is a really important word. We're going to use this word quite a bit. And it's called the scale factor. Now remember, all three sides have the same ratio. Do you see that? If I compared one side to the other, it's going to equal the same fraction as this is, and it's going to equal the same fraction as this is. So let's think about that. First of all, I want to see if those two really correspond to each other. Look at this 6 right here. It's AB. So I come up here to my little triangle thing. It's AB. What corresponds to AB over here on this triangle? Without just guessing which side goes with what over here, XY has to go with it, right? AB and XY. They have to match up with each other. They have to correspond to each other. Does that make sense? So my scale factor is just doing a ratio between those two sides that correspond to each other. So let's compare like this left triangle to the right triangle, or the big triangle to the small triangle. So what would my scale factor be? It'd be 6 to what? To 3. But we always reduce it, so what would this reduce to? 2 to 1, exactly. All right? Watch what we're going to do here. Let's say that this is 5. Let's say, we don't know that. We'll call that little a right there. Is that all right? And let me make sure I do this right. B, C, and Y, Z. We'll call this B. And we'll call this one 12. I don't know if these numbers actually work out right with a triangle, but that's good enough. All right? It's good enough for what we're trying to do. Yeah, it probably won't even work out to be a triangle, but that's okay. That's not what I'm getting at. I just want to show you how to see these numbers. Now look at this. The scale factor is 2 to 1. What does that mean, though? Does that mean that this side is 2 and this side is 1? No, it means for every 2 you go here, you go what? 1 on this side. Or this is twice as big as this, right? Make sense? Now this is as easy as it's going to get, okay, when you go 2 to 1. It doesn't really get any easier than that. It will get much harder, okay, but right now it's really simple. So my scale factor is 2 to 1. That's really, really important. What I'm going to do is I'm going to set up something to solve, let's say, for A, all right? Let's say I wanted to solve for A. First thing I do is this. I write down my scale factor. Do some different color. I write down my scale factor. And remember, the ratio of the corresponding sides have to equal each other. So 6 to 3 must equal the ratio of the other corresponding sides. So if I want to solve for A, look at A. A is AC, isn't it? Everybody see that? See, little a is that side AC. What side over here corresponds to side AC? Well, I went for the first one and the third one, so what am I going to do over here? X and Y. Or X and Z, sorry. X and Z. So XZ. So A corresponds to what? To 12. So watch what I did. My scale factor is 2 to 1. Now I don't know what that A is, so I just keep it A, but I do know that it corresponds to 12. Everybody see what I'm doing? I'm comparing the sides of the big one to the small one. I compared 6 to 3, which is 2 to 1, and then I compared A to 12. You understand why I did A to 12? Because A, this side AC, corresponds to this 12 side right here, which is XZ. And now, look what I can do. Now, I know you could probably just do that in your head, but let's do the math. All right? Cross multiply. 1 times A is A, and then 2 times 12 is 24. So that's what that side is. Now, again, I didn't draw this to scale or anything. These numbers actually probably don't work out correctly, because remember, the two smaller ones have to be bigger than the third side anyway. So really, with those sides, that's not even a triangle, but I just threw numbers in there. Okay, I just chucked in numbers. So that should be what? 24. How do I know that? Because the bigger one is twice as big as the smaller one, right? Should make sense. Now this is B right here. It looks like a 6 kind of, but that's a B. And if this is 10, or sorry, I tell you what, let's make this so it works. Well, I don't care. Let's just keep it this way. I don't care. If this is 5, how could we find this? Now, you could just do the math, couldn't you? This is half of that, 2.5. But I want to show you how we do this, because the numbers aren't always going to be this easy. Again, what do I start with? I start with that scale factor. I take 2 to 1, and I set it equal to 5 to B. 5 to B. How do I know 5 and B go together? Because this side 5 is BC. It's the last two. So that has to correspond with YZ. YZ is this one right here, and that's B. Hope that makes sense. Now we cross multiply, and we solve. I always like to do the letters first. So B times 2, or 2 times B, is 2B, equals 5 times 1, which is 5. Divide both sides by 2, and B is 5 over 2, or 2.5, or 2.5. And that's what that would equal. 5 over 2 would be perfectly fine. I'd be happy with that. Okay, either one, it's the same thing. Now let's do one that's a little bit more what you're going to see on the homework I'm going to give you. So let me draw this thing out for you, and this will be the last thing that we do, to go a little bit quick. And I'll tell you what, let's make this go a little bit shorter. Oops, come on, where is it? There we go. Alright, and I'm going to group it and copy it and paste it and just make it a little bit smaller, like that. And what they do here, I think they just rotate it around like that. Alright, and let's put some stuff in here. We say that A, C, D, and F. Everybody should be drawing this right now as I'm talking. That should be a Y, a Z, W and V right here. Alright, let's put some numbers in here. They tell you that that's 12, and that's 9, and that's X. And they tell you that this is 10, and 6, and 3y minus 1. Alright, so what we have to do is we have to solve for x and y. Running a little bit short on time, so I'm going to do this a little bit quick, but you can always go back to it and look at it. First thing I want to do is find my scale factor. Actually, first thing, they tell you, it's not a triangle, is it? They tell you that ACDF, now they don't put a little symbol here, because it's not a triangle, so they just say ACDF is similar to VWYZ. And that's really, really important. You can't really know anything about this unless you know that right there. Okay? So what I want to see the scale factor. Find the scale factor. And so that's got to be two sides that I actually know. Let's take a look at this 9 right here. 9 is CD, isn't it? Okay, well, which one corresponds to CD over here? WY, and that's a 6. Look at that. I know both of those numbers, don't I? So I know this is 9 and this is 6. So my scale factor is 9 to 6. But we always reduce it, so that reduces to 3 to 2. I'm going to put that in a box. It's not really my answer, but I'm going to use it. That's why I put it in a box to show you that it's important. Now let's solve for x. Now, if I'm going to take the scale factor 3 to 2, I went from the big one to the small one. So this is going to go from x to what? How do I know which one x corresponds to over here? Well, I'd look at this. This is FD, isn't it? Or DF. What corresponds to DF over here? YZ. So x corresponds to 10. Everybody see that? So 3 to 2 is a scale factor, and it corresponds to x to 10. Cross multiply. 2x equals 30, so x is 15. You can do the math on your own. Let's solve for y this time. So if I want to solve for y, that's this one. Which side over here corresponds to y? Well, this one right here is VZ, isn't it? So which one corresponds to VZ over here? AF. So the 12 does. So again, I use that same scale factor, 3 to 2. See how that's important? I used it twice. Equals what to what? Do I put the 3y minus 1 on top? No, I put the 12 on top because I'm comparing the bigger one to the smaller one. So I go 12 to 3y minus 1. And now you can cross multiply and make sure that you put that in parentheses and distribute. So that gives you 9y minus 3 equals 24. Add a 3 to both sides. That gives you 27. Divide by 9, and that gives you 3. And there's your x, and there's your y. This one doesn't say to plug it back in. Doesn't say find the lengths of anything. It just says solve for x and y. And that's how you do it. Okay, and that's the kind of stuff that you're going to be doing on the worksheet. They're going to give you pictures like this. They'll tell you what's similar, and they're going to ask you to solve for x and y or a and b or whatever letters they decide to put in there. Okay? All right, that's it. I'm going to give you the worksheet, and that'll be due tomorrow.